So so in a doubly reinforced section, now you have and tension reinforcement. Now, for in a balanced section, then you will have this formula dictating, and you can get the steel in stress and compression from two methods, which I just discussed from the code itself. Now, we'll straight away go to what is the moments that you have in and what happens in the compression reinforcement. For that, we can straight away go to the question to solve it. So what we'll be doing is we'll be taking up a question. Now the question is design a doubly reinforced beam section of dimensions 250 mm cross 475 mm. Now here यहाँ पर आपको डायमेंशन यहीं से दिया हुआ है. Why is the dimension given? Because you have a limitation on the dimension of the beam. The load on the beam is 20 kilonewton. No, we can let's take it 5 kilonewton per meter is dead load. 2 kilonewton per meter is self weight. The live load is 10 kilonewton per meter. Or let's take it 15 kilonewton per meter. Now the section is to be designed in M25 and we have Fe 500 steel. Now, what is the limitation set in the question itself? Which is in the practical एक limitation है, वहाँ पर dimensions आपको वहीं से दिए हैं 250 by 475. You cannot change the dimension of the beam. So our solution is like this. What was our first step? The steps are same. You are first of all calculating the moments and shear forces. Let us first draw the beam. Yes, one thing I forgot, the length of the beam is 5 meter. Now, this is 5 meter is the length of the beam here. The next thing given to you is it's 250 cross 475 mm. Now we have to design it as a doubly reinforced. For that, first we have to calculate the moments. what are the loads on this beam? The overall load would be how much? Dead load plus live load plus self weight. We're assuming the self weight here is 2 kilonewton. Now, how much is this? Or otherwise, you can calculate the self weight of the beam. How can you do that? Self weight आप ऐसे calculate कर सकते हो. Self weight is, what is the size of the beam? 0.475 meter into 0.25 meter into what is the length of the beam? 5 meter. You do not need to put the length here. Into 25 kilonewton per meter cube. What is it? It's the density of the reinforced concrete. This will be, कितना आएगा ये सेल्फ वेट फिर? This will be 2.9697 kilonewton per meter. So let us revise this. This self weight here is in the question. I am revising it. This is 2.97. This is 2.97. So self weight is 2.97. The total weight now is, dead load was 5 plus 2.97 is self weight. Live load is 10, 15. So the total load coming is 22.97 kilonewton per meter is the total weight. Now this is, again, we are treating it as simply supported. This is supported at the two ends. Thereby, now our bending moment diagram would be what will be the maximum? It will be WL square by, yes, someone, by 8. How much is that? WU is 22.97 into 1.5 into L square.
इसमें अल्टीमेट लोड नहीं निकालना है.
अल्टीमेट निकाला मैंने, 1.5 से मल्टीप्लाई किया, 22.97 into 1.5. That's giving you WU into L. L is 5 square. L square divided by 8. So this is coming to be 107.67 kilonewton meter. So this value here is 107.67 kilonewton meter is the maximum value here for bending moment. So then you have shear force. The maximum value of shear force would be VU is WL by 2, that's 22.97 into 1.5 into L is 5 divided by 2. So this would be equal to कितना आ रहा है 22.97 into 1.5 into
86.
2.6.13 or 14 kilonewton. This is the value of BU shear force. So having calculated MU and VU, then you move to step number 2. In step number 2, what do? हमने क्या किया singly reinforced section में? We fixed the dimensions, but here the dimensions are already fixed. Fixed dimensions. You cannot change these dimensions which are given to you. They are due to architectural requirements, or you have certain other issue. So it's fixed. It's 250 cross 475. So your B is 250 and your D is 475 mm, and you cannot change it. Now, what will be the effective depth? Yeah, that will be 475 minus the cover. For example, it's moderate condition, so it will be 30 mm is the cover minus, then the stirrup, for example, that's 8 mm stirrup minus, you have the bar, for example, it's 16 mm, so divided by 2, a half. So this is the effective depth after you are decreasing the effective cover from the overall depth. So this comes out to be 429 mm. Now if this is 429 mm, the effective depth of this, you have 429 is this, from this point till this point. You would also have in a doubly reinforced D dash. What is D dash in a doubly reinforced beam? Now you also have a compression reinforcement here. So you would have also cover here on this end. So this cover is D dash here. Let it be 30 mm is the effective cover, then you have 8 mm is the stirrup. Then again, let's have 12 mm as the compression bar, it uska half. So this would be 38 plus 6, that's 44 mm is D dash. From the center of this bar, from center of this bar up till this point is your D dash. There is always a ring over here. So that's, I have assumed that to be 8 mm, और हमने ये assume किया है this is at this point 16 mm, and this we have assumed to be these compression reinforcement is 12 mm. So the dimensions are right now fixed. Now, if I use the logic of D minimum required, now where does that come from? And the D minimum required. What was D minimum? How did we get D minimum or D required? How did we get this? How did we reach to this equation जहां पर हमने लिखा root of did we say root of yes mu by r fck into b? Was this the equation for D minimum required? Where did we get this? Mu was mu limiting. So what is mu limiting? Yes, any one of you? What was mu limiting?
It is balanced section.
A little bit louder. Hanji.
It is for the balanced section.
Was for a balanced section. Now,
Yes, sir.
can we यहाँ पर what is the mu limiting and what does it depend upon? Mu limiting would depend upon, if you recall the equation, I will just go back to that equation in annexure G. Now, this was the equation for mu limiting 0.36 xu max by d, 1 minus 0.42 xu max by d, fbd square fck. So it would depend upon bd, b and d, and fck. Now, in this question, for a doubly reinforced section, you have both b, d, which are the dimensions, as well as fck fixed. So it's xu max by d is also fixed. It depends upon the grade of steel. For Fe 500, you have xu max by d as 0.46 or 0.48, somewhat like that. Then this whole mu limiting is now fixed here. Now, if I calculate mu limiting here from that equation, 0.36 xu max by d 1 minus 0.42 xu max by d into b d square into fck. ये कितना बन रहा है? This is 0.36. What was xu max by d for Fe 500?
0.46.
0.46 into, this is 1.42, this is 0.46. B here is 250. D is 4, no, D is 429 square into FCK is 25. So you have this as This is coming to be 153, 681, 229 Newton mm, which would be 153.68 kilonewton meter is your mu limiting. So probably we need to revise this question. Why? Because your mu limiting is coming to be 153.68. And how much is the mu that you require? It's less than mu here is less than mu limiting. So you do not need to design it as doubly reinforced. You can design it as singly reinforced, because then when mu is less than mu limiting, it is under reinforced design. So in the next class, we will revise this question itself, and we will solve this as a doubly reinforced section. We just need to increase the amount of load here in this question so that we can solve it as its doubly reinforced section. So this was to give you an idea what is doubly reinforced, why do we require doubly reinforced section. Now, if your mu here was greater than mu limiting, then you could not go for an over reinforced section. What you needed to go do then is go for a doubly reinforced design. Why? And how does it solve this? ये आपका mu limiting जो ये this equation, this is telling you that all the compression load, this is 0.36 all this 0.36 xu max into this is compression load, and then you are multiplying it by the lever arm in the compression. All the compression for in this equation mu limiting is taken by the concrete. Now if your mu is greater than mu limiting, you cannot go for over reinforced section. Then you are adding the compression reinforcement such that the limiting capacity in compression is actually increasing then, and your equation is still becoming then balanced, जो कि हमें ये चाहिए, a balanced section approach or an under reinforced design approach. Then we need mu to be always less than mu limiting, even when your section has got dimensions fixed and there is a large load. So then your mu will be your load. It has to be less than, in a doubly reinforced section, mu limiting plus m of the compression, m taken by the compression reinforcement. That should be your equation then. So we will revise this question and we will solve it in the next class. Probably we might have that in a couple of days. We'll take another class. Okay, so anyone has any question?